Alrighty, we're diving into Module 7, and we're going to be talking about inequalities. And you know from your language arts classes, when you've studied this kind of stuff, a prefix of in means not. And so when you get your notes out here, this is what we are talking about. We want our essential question to be, how do I write and solve inequalities? Bing, bing, bing. There we go. So first we'd better come up with just a definitive vocabulary definition for inequality. And basically here's what I'm going to have you write down. It's a math sentence. But instead of having an equal sign, it's going to have one of these inequality signs. And what that means, that the two sides aren't equal. Which means we're going to have to use one of these 5 signs. Here's how we read these. The first one, less than. Next one is greater than. When it has half of the equal sign in there, then we say less than, this is hard to write all this, or equal to. It won't be both at the same time, so that's why we have to use the word or than, or there. Same thing here. It could be greater than, or it could be equal to. And the last one with the slashy bar through there, not equal. All right, so let's take a look at kind of how we represent this when we're looking at a less than sign, okay? This compares the smaller number, in this case, is going to go on the left, okay, because the pointy end always points to the smaller value. The open end is open to the larger value. So I could make a statement like this: 2 is less than 7, for example. And that's true. I know that 2 is smaller than 7. Algebraically, what if I said something like this? X is less than 3. Well, what's a number that's less than 3? 2, 1, 0, 1.7, 2 4/5, negative everything. So here's the deal. When we're trying to talk about what's a solution to this inequality, there's an infinite number of solutions. Oh my gosh, we could never list them all. We'd never leave the room. That would be awful. So here's how we represent all of the solutions to this inequality. You need to draw a number line here, okay? And on our number line, let's here make a spot for where 0 would be, and we'll get to 3. Here's 3. Now, before we do anything on here, and I'm going to change colors just so it's really obvious. When I'm saying it has to be less than 3, could exactly 3 work? Is 3 less than 3? No. So I can't include 3, but I can include absolutely every single number before 3, like 2.9999999999999. Okay, see what I mean? So put an open circle here at 3 and put it right on the line, not above the line, on the line. Make it so that it's open at the 3, and we need to include every single number in this direction. And notice that's how your arrow is pointing. So what we do is basically we kind of make this look like it's filled in and a lot thicker than this side of the number line, and take the arrow and fill it in solid. So it's completely filled in. That tells us that we start at 3. We don't include 3, but we include every single solitary value and number all the way to infinity to the left. All right, let's take a look at greater than. Greater than looks like this. 4 is greater than -1. That's a true statement. What if I said x is greater than -1? What does that look like? Well, there's tons of numbers that are bigger than -1. 0 is bigger than -1. 7 is bigger than -1. There's tons of numbers that are bigger than -1. Draw a number line. Make sure you always show me where 0 is, and then show me this significant benchmark number here, this -1. That's the one I care about. That's where I'm kind of beginning all of my information. Now, I can't say that -1 is a solution. -1 is not greater than -1. Nuh-uh. So I'm going to put a circle here, and I'm going to make sure that it's open to indicate I get close to -1, but not. Okay? And then since this is greater than, I want every number bigger than this. So I'm going to shade or make my number line bigger to the right. Notice that's just like the way your arrow is going. And then make this arrowhead filled in so it looks distinctly different from the other end so I can tell which way I want to go. All right, let's look at this one. This said less than or equal to. All right, so if I gave you something like y is less than or equal to 6. There are a lot of numbers that work here. And this time, is 6 less than 6? No. But is 6 itself equal to 6? Yeah. So because we use the word or, it didn't satisfy the less than part, but it does satisfy the equal part. So when we go to graph this one, and if you're graphing by hand, if you don't have a number line provided, I like you always to put the 0. Tell me where positive 6 is. You don't have to put all the intervals in between. I know 6 is to the right of 0. Put it there. This is my number that I'm starting at, 6. But because I have the equal sign, I can include 6. So I need you to make that dot filled in. That tells everybody that you include 6 as part of your list of solutions. Now we're going to the left because it's less than, this way, to the left. Fill in the arrowhead so it's obvious. Ta-da! Greater than or equal to. All right, so let's say I have z greater than or equal to, what? Oh, let's be fancy and use a decimal. How about 1.3? Okay. Here we go. Draw a number line. I always want you to show me where 0 is, unless they give you one that's provided. But if we're drawing by hand, here's 0. Here's 1, let's say. And then if that was 2, let's say 1.3 is about right there. Okay? Squeeze that in there. Greater than or equal to means I'm going to shade to the right everything. I'm going to start at 1.3 and I get to include 1.3 because 1.3 isn't greater than, but it is equal to. So fill in the dot, shade, make your number line nice and filled in so I can tell, oh, I'm starting at 1.3 and going to the right, to the right, to the right. Cool. That means every number here, 2, 1.4, 99, all of those are in the shaded region and they are solutions. The not equal sign, if I said something like x is not equal to 2. Boy, that's a lot of numbers because not only do you get something like 4, 5, 6, 7, 8, all of those, you have -5, -10, 0, 3.7, pi, all kinds of numbers aren't 2. So here's how we'd show this one. Here's 0. Always show me 0. Here's 2. Since I can't be equal to 2, 2 is not a solution, but I'm kind of gauging everything around this number. So put an open circle at 2. This one, we have to shade everything to the right because all of these numbers aren't equal to 2, and shade everything to the left. These aren't equal to 2. Ta-da. All right. Cool. Now you're familiar with how inequalities work, what it looks like when you graph them. Now we got to talk about how do we solve inequalities if we don't have the variable all by itself. So I want you to write this down under this box that says the addition property of inequality. If I said something like 4 is less than 10, okay? Write that down. Actually, let's do this. I'm going to erase this. I'm going to have you write this twice, okay? I'm going to have you write 4 is less than 10 over here on the left. And I'm going to have you over here write it again. 4 is less than 10. All right. I'm going to ask you to add a positive number to both sides of this inequality. So I'm going to add, what should we pick? 5. Let's add 5. Add 5, add 5. Now, when I do that, I change the inequality because now it says 9 and now it says 15. Is the less than relationship still true here? Is 9 less than 15? Yeah, that works. What if I added a negative number? Let's add negative 2 to this side, and let's add negative 2 to this side. Do the same thing. Be fair. Now I would get positive 2, positive 8. Is this inequality still true? Uh-huh. So what this means, you can add the same number to both sides and it stays true. Okay? Doesn't matter what you add to both sides, it stays true. Okay? Guess what's going to happen over here? And let's use the same stinking thing. 4 is less than 10. Leave a lot of room in the middle. 4 is less than 10. If I subtract 3 from each side, here's what happens. I get 1. I get 7. Is it still less than? Yep. I should use a greater than sign in there or something different, but you're just going to have to trust me that it's true. If I subtracted negative 4, subtract negative 4, would this still be true? I get 8, 14. Yep, it's still true. So it doesn't matter what you subtract to each side. You can subtract anything you want as long as you do the same value to both sides. So if I say subtract from both sides, it still stays true. That's an important relationship and a property to notice because we're going to go to town and start solving inequalities. So here we go. You're going to find out this is just exactly like what we were doing with equations. All right. Instead of the equal sign, you have an inequality symbol. Draw your line right under there. -5, -5. Yay, hooray. That goes away and you get your variable by itself. That's exactly your goal. So over here where it says questions, get the variable isolated. Ta-da. So, hey, do you remember what -12 minus 5 is? It's -17. Hot diggity dog. Now, I know you have a whole bunch of things on here, but I'm going to ask you kind of ignore the intervals. Just put 0. Let's put 0 about here. And let's say this down here is negative 17. We are going to graph everything less than this number. That means this way, okay? Take this arrowhead and fill it in. We're going to start at negative 17, so make sure you color in the number line this way, but leave that circle open because I only have a less than sign. Can't include negative 17, but I can get right up close to it. Hey, turn the page of your notes. Let's look at a few more. Let's solve this guy. Put a line under here, add 3, add 3. Yay, hooray, that goes away. I have now isolated my variable. 8 plus 3 is 11. Holy cow, this is weird. First things first, if my variable is on the right-hand side, we need to rewrite this thing. I like to always put the variable on the left. So we're going to put the y here, and we're going to put the 11 over here. Now, take a look. This open end, the big opening, is pointing or chomping, opening up towards the 11. The pointy end was to the 11. I should say to y, and the pointy end is to 11. And put an equal sign underneath. Y is greater than or equal to 11. Okay, it's positive 11, so it'll be up here somewhere. Throw 0 down here somewhere. I don't care about the intervals. I just want you to show me. 0's here, 11 is to the right. We put a circle at 11, and we are shading greater than. So we're going to the right. Color this in and make that arrowhead huge and colored in. Now, because I have the equal sign, color in your circle on the 11. That's all you got to do. All of these are solutions. Cool. Let's do the next one. Get the variable alone. Add 5, add 5. Yay, hooray, that goes away. I get y is greater than or equal to negative 7 plus 5. Negative 2. Here's my number line. Cool. I don't even have to put my numbers on here now. Put your circle at negative 2. That's your significant number, our benchmark. We want greater than or equal to, so we're going to shade this way. Blah. Sometimes I just do a squiggle and make big fat arrowhead. Okay? Big fat arrowhead. I have the equal sign this time. Color it in. And last but not least, this one. Here's my variable. I am adding a positive 12, so I'm going to subtract 12 from each side. Yay, hooray, that goes away. I get 9 greater than x. Ooh, I don't like this. Rewrite this. Blah, blah, blah. I like my variable on the left. Put x here, put 9 here. The pointy end was pointing to x. Okay? 9 greater than x is the same as x is less than 9. Pointy end to the x. My significant number is 9. Put an open circle. I'm going to shade to the left. So I'm going to shade all of this stuff here. Leave your circle open because you only have the less than sign. All right, we're going to stop here. I want you to grab your packet. And in your packet, your assignment for the next time I see you is going to be this. All right, so as you get your packet out, we're going to do page 1. Okay. Page 2, extra, I want you to do just these ones down here. So from 21 to 28. Okay, so you're going to do page 1, which is 1 through 14. On page 2, you're going to do 21 through 28. And then on page 3, do these ones, which is what, 1 through 12 more. All right. Now, don't freak out. This goes pretty quickly. You're just doing a bunch of graphing and solving. All right. Whew. Good luck. Watch your dots, whether they stay open where you just have greater than, less than, or if they're solid, and that's where you have less than or equal to. Good luck. May the force be with you.